Okay, welcome back, Maths fans, to another Maths Watch help clip. Okay, this time we're looking at clip 140, which is simultaneous equations solved graphically. We're looking at the harder question, question 2. And some information already given in this question. So we haven't solved the equations here somehow. Here is the graph of 2x minus 3y equals 6 from x values from 0 to 4. So that's what we've got there, 0 to 4. By drawing a second graph, we're going to work out the approximate solutions to 2x minus 3y equals 6. We've already got that one. And 2x plus 3y equals 3. So what we need to do, if we know anything about simultaneous equations, is we need to find, to plot this graph over the top of the other one. And where they intersect, that'll be our solutions. So how do we do that then? Well, plotting 2x, again, there's lots of choices of how to do this. If I was looking at this now, I'm probably thinking, okay, 2x plus 3y equals 3. A good way for me to start, I'm going to put x equals 0 in there. So I get 0 plus 3y equals 3. So y would be equal to, if I divide both sides by 3, y equal to 1. So that gives me one coordinate, which is 0, 1. For the second coordinate, I might put y equals 0. And I'm going to get 2x plus 0 equals 3. So 2x is equal to 3, x is equal to 1.5 or 3 over 2, whichever way you want to write that. Give me a coordinate 1.50, so that's okay. And what else would I use? Well, I've got two coordinates. I can try for a third here. What am I going to go for here? So what about x equals, I'm looking for something nicely that would divide by 3 or 2 here actually. So how about y equals 1? We've already got that one, haven't we? Sorry. Y equals, where are we going up to here? Y equals 3, perhaps. Is that going to be nice? Y equals 2 would give us 6. 3 take away 6. Not so nice. What else could we use here? Let's go for y equals 3. It really doesn't matter too much here. So we get 2x plus 3 times 3 equals 3. So 2x plus 9 equals 3. 2x would be equal to, we take away 9 from both sides, minus 6. X therefore equal to negative 3. That worked out quite nicely at the end, didn't it? I mean, if you don't like the coordinate you get, you can always try for another one. There's no limit on this. The point is, you just try and get some nice coordinates that you can plot here. So x is minus 3, y equals 3. So substituting those in now, so plotting those, sorry, onto here then. So these were the coordinates. I can get them all on the same, just about get them on there, can't I? Yep. Okay, so 0, 1 is one coordinate, so 0, 1. Second coordinate was 1.50, which is here. Looking good so far. And negative 3, negative 3. Well, we're not going to get that on there, are we? So we really need something in there, really, to check it. What about when x equals 2 then? So as you can see, you know, sometimes you try this and you realise it's not going to work. X equals 2. So we try another one. So we get 2 times 2 plus 3y equals 3. So we get 4 plus 3y equals 3. Take away 1 from both sides. We get 3y equals minus 1. Y equals negative a third. Now, not a nice one because it's hard to plot that one, isn't it? So you're going to get 2 negative a third. We know that that's a recurring decimal, very hard to plot accurately, so I'm not going to use that one either. What else can we use here? Anything else that looks like it might work? Looking at this, maybe x equals 3. Maybe x equals 3 then. So, you know, still trying. X equals 3. What do we get? 2 times 3 plus 3y equals 3. 6 plus 3y equals 3. This looks a bit better, doesn't it? 3y equals minus 3. If we take away 6 from both sides and divide them by 3, we get y is equal to negative 1. Okay, so that looks okay. So what have we got there? 3 negative 1. So what you're seeing here is, even somebody who's been doing this for a long time, it isn't always obvious which numbers to choose first. Sometimes we have to try a few to get a nice coordinate. So 3 minus 1 is the last one we've got there. So 3 across, negative 1 is here, not there, is it? Because we look at the scale there. And luckily, well not luckily, but we know we are here, those 3 are in a straight line. So lovely, we've got that equation. So that's my 2x plus 3y equals 3. Where's the solution then? My approximate solution is going to be here, isn't it? Okay, so it looks like, what have we got there? We've got 1, 2.25, I'd say 2.25, and y, looking at this here, is minus 0.5. So x 2.25 and y minus 0.5. So x equals 2.25 minus 0.5. Okay, took a bit of time, but we got there in the end. Hope that makes sense, and I'll see you next time.